All right, so for logarithmic equations, you're going to see that the variable is inside of the argument. And the first step is you got to get it as a log is equal to something. So in order to do that, you might have to use your log properties, but you got to get it into one of these forms. You either have log is equal to a number, that would be an appropriate form that you can then deal with, or log is equal to log. Now, if you have the log is equal to a number format, then what you can do is you can just revert back to the raise equal to wave. If you have log is equal to log, then you can set the arguments equal. Okay? All right. So in this particular question, number 58, you don't have either of these forms. So what you need to do is you first need to condense. And you want to either have log is equal to a number or log is equal to log. So to start off 58, you need to notice that you have two logs being added. And by our log properties, when we have two logs added, that becomes multiplication of those two arguments. So this would be x plus 3, x minus 3. Okay? And it's one log, all of that is the argument, equals 2. Now, at that point, it is in an appropriate format. It's in log is equal to a number. So once it's into the log is equal to a number, you can do the raise equal to. So you can say that this is 4 to the second power, and then that will be equal to x plus 3, x minus 3. Okay. Now, once you get out of the logarithm, you have made some progress, but it's kind of like, where do I go from here? So you can take 4 squared, that gives you 16, and you can FOIL this out. You can say that this is x squared minus 9. So hopefully once you FOIL it out and actually compute what the 4 squared is, you're saying, okay, I have highest power of 2, so I have a quadratic equation. I could move everything over to one side, or I could say I just have an x squared as the variable, so I can add 9 to both sides and get 25 is equal to x squared. Now, a squared, we need to have 2 answers, and we can undo the square by taking the square root. But when we have our 2 answers, we're going to have a plus or minus square root of 25. So that will give us that x is equal to plus or minus 5. Now, it's very tempting to be like, it's a done deal, it's going to be 5 and negative 5. But that is not the final answer. Because if you remember, the logarithm is not defined for a negative argument. So the one thing that's a little weird about log equations is with log equations, what you need to do is you need to check that you have a positive argument. And I always think about this as you're checking for a positive parenthesis. So you need whatever is inside those parentheses to be positive. So if I go back to the original equation was log base 4 of x plus 3 plus log base 4 of x minus 3 is equal to 2. And I need to plug in my proposed answer of 5 and see if it gives us this positive argument. So I have log base 4 of 5 plus 3 plus log base 4 of 5 minus 3 is equal to 2. Now, I don't really care what log base 4 of 8 is and what log base 4 of 2 is. What I'm after is this a positive argument? And it is, because 5 plus 3 gives us 8. And is this a positive argument? And it is. So because those are positive arguments, I know I'm good to go with the x is equal to 5 solution. So I then check the x is equal to negative 5 solution. Now, just because the solution is negative does not mean it's going to be a problem. The question is, do you have a positive argument? Do you have a positive parenthesis? So when I plug in the negative 5, okay, it's only when I see that this parenthesis evaluates to negative 2 that I say, no, that's not going to work as a solution because I have a negative argument. And we cannot have a negative argument. So remember, we went through the whole thing about if you punch it on your calculator, even though it's a different base, log of negative 2, it's going to say it's a non-real answer. So this does not work for us. The negative 5 is not an answer. It is an extraneous solution. And we have to say that the only answer is x is equal to 5. Okay? So with our log equations, what we're doing is we're getting one log is equal to a number, or we're getting log is equal to log. If it's a log is equal to a number, we do the raise equal to. If it's log is equal to log, we're going to set the arguments equal. But as you go through that and you solve the resulting equations, the big thing that you have to remember is to check for a positive argument, a positive parenthesis, in order for it truly to be a solution.